derivative, and then so to do the first derivative test, to find your critical points, we're going to set this equal to 0 and solve. Now they all have an x and they can all be divided by 4, so I'm going to take a 4x out and I'm left with x squared minus 6x plus 9. So then I solve. Oh wait, not fully factored. Here we got 4x is one factor, another factor is x minus 3, and then the other one is x minus 3. I could have wrote x minus 3 squared, but I suppose it doesn't matter. If I set these factors equal to 0, I get x equals 0 and x equals positive 3. Why is 0 and 3 a solution? Because if I plug 0 into all of these x's, I will get 0. If I plug 3 into all those x's, I will get 0. So these are critical points. What are critical points? Critical points are where the curve that we're graphing is where the curve has a slope of 0. So most of the time you're going to get a max or min at your critical points. However, there are instances where you don't get a max or a min. Let me show you and remind you. We have a min right there. There is a max, and here you go. Weird funky thing happened right there. I have 3 points right here. They all have a slope of 0. One of them is neither a max or a min. This one. It's not a max or a min. How do I know? Because it's decreasing before the point and decreasing after. In order for it to be a max or min, it has to be switched. Like right here, it's decreasing and then increasing. Over here, it's increasing then decreasing. So we got extrema right here and right here. Not right here. Alright, so are both of these, do they give us extrema? I don't know yet. One way you can find out is by making a sine line graph. So I have one at 0 and I have one at 3. Those are my critical points. Now if I want to find out if my curve right here that I'm trying to graph is increasing or decreasing, I just need to know the slope, whether the slope is positive or negative. Y prime gives a slope. So you could pick a point or pick a number before 0 to see if the function, the curve, is decreasing or increasing right there. So let's pick -1. If I pick -1 and plug it into my slope function, my slope equation, do I get a positive or a negative? Now don't write this. I would hope that you try to do this in your head. You would plug it in. You would go 4, -1. Doesn't matter. As long as you pick a number that's before 0. And so we have 24, -1, and square that guy, plus 36, and then we have a -1 multiplying to him. So we have a -36 right here, we have a -24 right there, and that's going to be a -1 times whatever that is, -4. So this is definitely going to be negative, right? Right. You could probably do that in your head. Okay, what do I get in between 0 and 3? Okay, so we get a positive for this interval and a positive for this interval. Now I'm not plugging in a number right here for you guys just because you can do that on your own. But we get decreasing, increasing, increasing. That's what's happening for our graph. And so I'm going to graph our graph on this graph right here. And I'm going to put our critical points as dotted lines. It's weird because you're saying points, but these are dotted lines are very important because that's potentially where this curve changes from increasing to decreasing or decreasing to increasing. But we can see right here that the curve is actually going to decrease right here and then stay increasing for the rest of the graph. All right. So we have an idea of what's going on. Let's also do our second derivative test. So we got to get our second derivative going on right here. So we take the derivative of the derivative. So we get 12x to the second power minus 48x plus 36. We set this foo equal to 0 so we can find our inflection points, our possible inflection points. I can take out a 12 from all those. So I'm going to divide both sides by 12. Yeah, let's do that. So then I get x squared minus, what is that, 48? Oh, no, it's just 4. And then we have plus 3 equals 0. To factor this, I get x minus 3 and x minus 1 because we're looking for two numbers that multiply to give me positive 3 but add to give me negative 4, and negative 3, negative 1 fit that description. And now I found our two possible inflection points. Oh, man. Okay. It's 3 and 1. I'm going to go ahead and draw that on our graph where our curve is going to be. We have one right here at 0, and one right here. No, not there. Where's the other one? No, not at 0. It's at 1 and 3. How come you guys didn't stop me? Too busy writing and not knowing what's going on, Mr. Patey. Oh, man, I hope you're not that lost. Okay, so we can do a sine line graph for this one just like we did for the first derivative test. So let's do that. I'm going to draw this. I got a 1 right here, and I got a 3 right here. So if we want to know if this curve is concaving up or concaving down, what we need to do is we need to use the sine line graph right here and pick numbers in each of these intervals. One number before the 1, one number between the 1 and the 3, one number after the 3, and plug them back into our second derivative to see if we get a positive or a negative number. That will tell us if the curve is concave up or concave down. Negative would be concave down, positive would be concave up. Let's use this one right here because it's a little simplified to that one. I like this one better. Okay, so let's try 0 first. If I plug in 0, what do I get? Positive. So that's concave up. Yeah. Some write positive, some like to just write the concave up sign right there. If I plug in 2, let's see what we get. That'd be 4. That'd be negative 8. That'd be a 3. 3 and 4 is 7. Negative 8. Okay, negative is what we get, right? Mm-hmm. All right, so we get concave down right there. And then, let's see, the last one. Let's plug in a 4. 4 squared would be 16, and that would be 16. So 16 minus 16 gone, and then we have a positive. So we do have a concave up going on right there. All right, now that's kind of interesting. Okay, now to draw our curve, what we need normally is we need a point. Now you can really start anywhere unless you know a point. If you know 1 point on this line, like 1 point off of the table for this line, then you can start at that point. What's the easiest point? At 0, right? So 0, negative 1? Yeah, you guys in agreement? If I plug 0 in to the x's, I get negative 1. Okay, so before this point, our curve is decreasing. And in this area, are we concave up or concave down? Because there's two decreasing lines I can draw. I can draw a decreasing line like this, or I can draw a decreasing line like this. Both of these are going down. Both of these curves. I shouldn't say line, I should say curve. This one's concave up, and this one is concave down. But what are we doing in this area? Let's see. Before 1, we're concaving up. So we need to draw this curve, not this one. So we're just going to go like this. Bam. Okay. Right when we get there, because we're on our critical point, we know we need to have a slope of 0. And at this point, we then change. We start increasing, says the first derivative test. And as we're increasing, before I get to this purple line right here, are we concave up still, or are we concave down yet? We're still concave up until we get to the 1, which is this purple line right here, right? Right. Okay. And actually, maybe I should have lined up my my graph like this. Just pop that over there. So this one right here is lined up with that. I don't know. Okay. Let's see. We're concaving up, so we're gonna go up, and we're concaving up. But boom, we hit that, and then something changes. Right at 1, we're still increasing, but then we're concaving down. So there's 2 different types of increasing curves that we can draw. We can draw an increasing curve like this, or we can draw an increasing curve like this. This one is concaving down, this one's concaving up, and which one do we need right now? Down. So we're going to change the way this graph is increasing, and then boom, we hit that. And then what happens right there? Not only do we have a slope of 0 because we're on this dotted line, but then we're also increasing and we start concaving up again. So we got boom. All right. So right there we have a slope of 0, and right here we have a slope of 0. Boom, that's our curve. And it's just a sketch, people. It doesn't have to be perfect. That was a good comment and a good concern, so I want to address that. This does say graph. Okay, a lot of times these questions say sketch. because in a sketch is a less exact curve. You don't have to be extremely exact. Most of the time, you won't need to find the exact critical point. Can you? Yeah, if it's easy, do it. But I don't know. Most of the time, that's not that important. What is important is that you know what the first derivative test tells you and what the second derivative test tells you. And so you understand these dotted lines I drew right here. You understand the increasing, decreasing, and the concave up, concave down. That's what you need to know, because that's calculus.